Hello everyone and welcome to episode 2, Plotting Raster Data in R. We're going to be continuing in this lesson working with rasters and plotting our data with R and extending our knowledge of different plotting tools. Just as a refresher, we are in our C drive, in our users folder. I'm in Maria in my desktop and in that Geospatial CARP folder that we had created earlier. And this is in my console I'm looking at here. My environment is empty. I'm starting with a new RStudio, a clean slate, so we haven't saved anything from our previous episode 1. In this pane here, I'm also told the same information. Again, I'm in my C drive, users, Maria, desktop, and that Geospatial CARP folder. Within that folder, we can see here that I have my geospatialcarp.rproj file. We have that episode 1 intro to raster.r script that we created in episode 1. And I have my data folder here that has the different data sets, raster and vector data that we are using. So with that, let's go ahead and create a new R script. So I'm going to create a new R script and it's going to look something like episode 1 underscore intro raster.r, except it will be for episode 2 now. So I go to File, New File, R script, and now we can see that my console has shifted down a bit and I have this new R script. So I'm going to add some information to the header again. So this is going to be plotting raster data in R. I'm going to set just the year, I think, for here, so 2020. My name. And a little bit of information about what the script is going to contain. So I'm going to say this is part of episode 2 of Geospatial Carpentry. In this lesson, we are learning more about plotting raster data in R. So specifically in this lesson, our objectives are to build customized plots for single band rasters using the ggplot2 package, and to learn how to layer rasters on top of each other. So with that, let's go ahead and load the packages that we will be using. So if you're continuing with the same script that we had created in episode 1, you don't need to reload these packages, they're already there. I prefer to start with a blank slate just to keep things clean. So I'm going to type, we're going to use the packages raster, so library raster, library ggplot2, and library rgdoll, and finally library dplyr. So again, I can run these by pressing Control-Enter. Looks like raster takes a while to load. Control-Enter, or I can highlight multiple lines and press Control-Enter. Again, notice that we have some warnings, it looks like in red. These are actually not errors, so when R gives you an actual error, it will just not run. It'll be very clear and evident when it's an error. So just because these warnings and messages are in red, it doesn't mean that something went wrong. This looks absolutely fine. So something to notice here, again, my R script, it says untitled 1 star and it's in red. This tells me that my R script isn't saved, so I'm going to save it by pressing Control-S, or you can go to File and Save As. I'm going to save it as episode 2, plotting raster.r. So notice now that my script comes up here in my files panel. And now that untitled 1.r is no longer there, and we're told that the script is episode 2 underscore plotting raster.r. All right, so since we're starting with a clean slate, we're going to have to reload all of the raster data using the tools we learned in episode 1. Again, if you're continuing with the same script, you don't need to do that, but I will go ahead and do that here. So let's go ahead and load in some rasters. So we're going to recreate DSM underscore harv. And I'm going to use the raster function double quotes, and I'm going to go into my data folder, into the raster subfolder, and I'm going to select harv_dsm crop.tif, and then I press Control Enter, and we can see now in my environment panel, this dsm_harv is in my environment, and we're told already that it's of formal class raster layer. So it looks like that loaded just as we needed. And then we'll also go ahead and create dsm_harv_df. Recall that we need to transform our raster layer into a data frame in order to use ggplot with it. So we type as.data.frame, open parentheses, dsm_harv, which is the raster we loaded in above, and we have to specify the argument xy equals true. And press Control Enter. Again, in our environment panel, we see that dsm_harv_df is now an object. It's loaded in our environment, and it's an object that has 968,044 observations and 3 variables. If we want to just see a little bit more about what's contained in this data frame, we can look at the structure using the str function and do str of dsm_harv_df. I press Control Enter. And down in my console, again, we're told the same information, that I have 968,044 observations, 3 variables. I'm told that it's of class or type data.frame. And I'm told a little bit more information about the 3 variables. So X, we're told that the 3 variables are X, Y, and this harv_dsm crop, that they're numeric. And we get the first, looks like the first 5 or so observations for each of these 3 variables. So now that we're fairly caught up with what we had installed or had loaded in our previous episode, let's go ahead and dive into plotting data using breaks. So we're first going to start with plotting some histograms again. So I want to add a new variable to my data frame, dsm_harv_df, and we're going to do this in a tidy way using dplyr functionality. So dsm_harv_df is going to be on the left-hand side, and we're going to use the mutate function to add a new variable. So the input data frame is, again, this dsm_harv_df. We'll use this pipe operator, and we use the dplyr function mutate, and we are going to create a new variable called FCT, or short for factor_elevation, equals, we're going to use this function cut. We're going to cut harv_dsm crop, which is this variable in our data frame right here, our variable of interest, sort of our outcome of interest. And we're going to cut that variable into three relatively similar groups. So I press Control Enter. So now if I look at the structure of dsm_harv_df, press Control Enter, we can see that we've created a fourth variable in our data frame called FCT, or factor_elevation. And we're told that it's a factor with 3 levels. Now let's take a look at these levels in a little more detail. So I can use the levels function, open parentheses, dsm_harv_df, money sign, factor elevation. So here I can see that what the 3 levels are. So we grouped elevation into 3 bins: 331 to 356 meters, 356 meters to 380 meters, and finally 380 meters to 405 meters. If we want to know how many observations are in each of these groups, we can use the table function. So that's table, open parentheses, dsm_harv_df, money sign, factor_elevation. I press Control Enter, and I see here that the number of observations that fall within each bin group. We can also use the function unique if we want to look at the different levels. So unique, open parentheses, DSM underscore harv underscore df, factor underscore elevation, control enter. And this gives us the same levels here. So it looks like unique and levels will give us similar information. Again, in R, there's multiple ways to get at the same thing, which is very good. All right. So the next thing we want to do is to create a count. So by this new variable we created, factor underscore elevation, we want to count the number of observations. So again, similar to what we did with table, we're going to do this in a dplyr way. So count number of breaks. So we're going to take our DSM underscore harv underscore df. We're going to pipe it to this new dplyr function group underscore by, open parentheses, factor underscore elevation. Again, we're going to use a pipe. And then we're going to use this new function count. So then if I press Control Enter, notice here we have the same information that we had using table as well. So again, just emphasizing there's multiple ways to do things in R, but it's helpful to know these two different ways depending on whether or not you want to take sort of a tidy dplyr approach or if you want to use base R functions. Both are completely reasonable and sort of depend on what you prefer. All right, so this whole episode is about plotting, so let's get into a little more detail about creating a really nice visualization. So we want to create some custom bins. So instead of using these bins that we created using breaks equals to 3, we want to create our unique bins. Maybe they're driven by scientific information or scientific knowledge. But I'm going to create an object called custom underscore bins. I'm going to concatenate 300, 350, 400, and 450. So these are the different groupings I want, because maybe cut point at 356 and at 380 really doesn't make sense for me in my scientific needs or sort of what I'm trying to visualize. In these groupings by whole numbers, or I guess groups of 50 or so, makes more sense for what I'm trying to do. So these are the custom bins we're going to create. I press Control Enter. Again, notice that this now becomes an object in my environment. And then I'm going to add a variable to DSM underscore harv underscore df, again in a tidy way. So this is going to be the input variable. I'm going to use the pipe. I'm going to use that mutate function again, open parentheses, and I'm going to create factor underscore elevation 2, underscore 2. So we're going to create a new variable, factor underscore elevation 2, and I'm going to use cut, so the same function we saw above. I'm going to cut harv underscore DSM crop, but now instead of specifying breaks is equal to 3, I specify breaks is equal to custom underscore bins. I press Control Enter. So let's use the unique function to see what those bins look like. So DSM underscore harv underscore df, money sign, factor elevation underscore 2, Control Enter. We can see that the different bins we assigned, so 300 to 350, 400 and 450, are the different levels that we see here now. Let's go ahead and look at the number of observations for each of these unique groups in a tidy way. So DSM underscore harv underscore df, pipe, group underscore by, factor underscore elevation underscore 2. We use the count function again, open parentheses. And if I run this, Control Enter, we now see the total number of observations in each of these unique custom bins. So now we've created custom bins and we want to actually get to plotting. So let's go ahead and create a bar plot. this down a bit. All right, so we use our ggplot function, open parentheses, plus, and we're going to use this geom_bar aesthetic. We specify data equals dsm_harv_df, and then we specify the aesthetic here, AES, geom_bar is a geom, not an aesthetic, pardon me. And we use the aesthetic AES factor_elevation_2, and we press Control Enter. Remember, there's 968,044 observations, so this will take a second. And in our plots panel here, we see that we have a bar plot. So we have our groupings that we created, our custom bins here, and we have the number of observations that fall into those bins plotted here. All right, so this is great. This is a very helpful visualization, but what if we want to bin these observations as we did here? So these custom bins, 300 to 350, 350 to 400, 400 to 450, but we want to actually plot those on the raster itself. We can do that as well. So let's custom bins on a raster. So we use, again, we start with that ggplot function. So ggplot open parentheses plus, then the geom is geom_raster open parentheses. We specify the data frame, so that's dsm_harv_df, comma, AES for the aesthetic, and we specify x is equal to x, y is equal to y, and fill, so the color that we want to be filled in, is equal to this factor_elevation_2. And lastly, recall we have to add this additional feature, chord_quickmap, open parentheses. Let's go ahead and run this. So I press Control Enter. And we see here our generated raster. And on the legends panel, we see those custom bins again. And notice here that there's very few blue spots or blue parts of this raster. And that makes sense, right? Because we saw earlier from the geom bar, there are very few observations that fall within that range. So this is another nice way to verify that our raster, the plot that we created, indeed makes sense and nothing went wrong. All right, so this is neat. We can group our outcome of interest, that harv_dsm crop into groups and color those groups in our raster. But let's get into some more plot formatting. All right, scroll this down a bit. All right, so what if we don't necessarily want to go with these default colors? We can also specify specific colors that we're interested in. So I'm going to create an object called my_call for my colors, assignment operator, and I'm going to use this function terrain.colors. I'm going to specify 3. So once we get through this visualization, you'll see what those terrain colors are. But the main point here is that this is a function for a specific palette of colors, and that I'm requesting 3 unique colors. Okay. So our ggplot is going to be very similar to what we just did above to create this raster over here, but we're going to add some modifications. So again, we start with ggplot, open parentheses, plus, then we specify then we use the geom underscore raster, open parentheses, data equals dsm underscore harv underscore df. Again, the aesthetic AES, x is equal to x, y is equal to y, fill is equal to factor underscore elevation underscore 2, plus we have to now, to create our custom colors, we use this additional function, scale underscore fill underscore manual. So intuitively, this makes sense. Don't use the default colors. Fill in things with a manual color that I'm going to give you. I set values equal to my underscore call, which we created right up here. And then I give it a name. So I say name is equal to elevation. And again, don't forget we have to add chord underscore quick map, open parentheses. So let's go ahead and run this, Control Enter. Oops. Looks like I forgot to add, to run my underscore call. It's always good to create the object that you want. So now I ran my underscore call. I can verify that it's created in my environment over here. Now let's go ahead and run our ggplot. Oh, looks like I have another typo here, pardon me. All right, so now let's go ahead and create our ggplot. And notice here, this is what an error looks like in R. So it specifically will tell you error. Something went wrong. Error here. Again, recall these rasters often take quite a bit of time to plot, especially if your resolution is very fine or if you just have a lot of data. And here we finally have our raster that we created. Notice this is the exact same image we had before, but there are two modifications. Most obviously, our color scheme has changed. So the 300 to 350 bin is in green. The largest bin, the 350 to 400 bin, is in this sort of, let's say, sandy color. And that's most of the area. And then that very small bin we had, 400 to 450, is this white area. So one nice thing about this color scheme is that it's much easier for us to see, right? This white on the sandy color is much easier for us to visually see than it was that blue on the green. Another modification that we created was by setting name is equal to elevation here. We created elevation as a label for our legend. We can also modify these axes as well. Instead of having things say X and Y, we can create some labels. So let's go ahead and modify the ggplot we just created. So I'm just going to add, so plus xlab, open parentheses, UTM easting, and that's in meters, plus ylab, open parentheses, UTM northing in meters, and let's go ahead and add a title. So I'm going to say GG title. Let's call it elevation map with terrain colors. Let's try that. So Control Enter. And now we have that same raster that we had created earlier, but with our additional modifications to the x-axis, to the y-axis, and then also our title. And with that, we're ready for our first challenge of this episode. So challenge 1, plotting using custom bins. We want you to create a plot of the Harvard Forest Digital Surface Model, DSM_Harv, that we've been working with. And we want this plot to include 6 classified ranges of values, or breakpoints, custom bins, that are evenly divided amongst the range of pixel values. We want this plot to have axis labels and a plot title. So this won't be a histogram or a GM or a bar plot. We instead want that raster with those 6 groupings of color. All right, so let's go ahead and go over solutions to challenge number 1. All right, so let's add a variable that will have these 6 different custom bins to our DSM_Harv_DF. So we already have the data frame created, so we don't need to do that again. We're going to do this in a dplyr way. So DSM_Harv_DF, we use the pipe operator to pipe that data frame into the mutate function, open parentheses. We're going to create factor_elevation_6 now, and this is going to be equal to cutting our outcome of interest, this Harv_DSM crop, into 6 breaks. We can press Control Enter. Let's go ahead and use the table function this time to look at the different groupings. So that's table DSM_Harv_DF. Money side, we navigate to this factor_elevation_6. We press Control Enter, and we see that we have these custom groupings that are about evenly spaced, and we see the total number of observations that fall into each one of those 6 groupings. All right, so the next thing we want to do is we want to update what my call is. So previously we had my call or my colors equal to 3 terrain colors, which corresponded to the 3 different levels that we created, the 3 different custom bins. In this case, we now have 6 custom bins, so we want to update my colors to terrain.colors, and now we want 6 terrain colors. And notice here, my call has now changed, and we're told that it's a character string or a character vector with 6 elements to it, and those 6 elements are those 6 colors, and these are hexadecimal color values. All right, so we've set everything up, and now we're ready to create our ggplot. So we start with the ggplot function, open parentheses, plus, we use the geom_raster, geom, open parentheses. Let me move this down a little bit so it's easier to see. Let's go into this geom_raster. We want to specify the data frame, and that data frame is DSM_Harv_DF, comma. Now we specify the aesthetics. So AES, open parentheses, X is equal to X, Y is equal to Y, comma, fill is equal to this factor_elevation_6 that we had just created. Now we want to use our custom colors, so we use scale_fill_manual, open parentheses, values is equal to my_call, comma. Let's give this a name to our legend, so name is equal to elevation. All right. So then let's go ahead and add those plot titles and axis labels. So ggtitle, open parentheses. I'm gonna call this, ggtitle, open parentheses. I'm gonna give this a fancier name, so I'm gonna call this classified elevation map, neon Harvard forest field site. Oh, that's a mouthful. All right, plus xlab, open parentheses, double quotes, UTM, easting, coordinate in meters, plus ylab, open parentheses, double quotes, UTM, northing coordinate in meters. And what's that last thing that we always need with rasters? I'm assuming you got it right. That should be cord underscore quick map. Oops. And there we go. That's what I want. All right, so again, this will take a little bit of time to load, but I think this looks good. Doesn't look like we have any errors this time. Always progress. And now we wait. All right, and here we have our final plot. So we have our 6 different colors in the legend here. We have a legend title. We have an X and a Y label. And we have our official GG title here. We have this beautiful plot, and now we can see a little more detail about what's going on in this field site. So great job on your challenge. So our next subject, I guess, will be learning how to layer rasters. So we can layer rasters on top of each other to create really beautiful visualizations that give us a lot of information about what's going on in a particular region. So in our lesson specifically, we want to layer a raster on top of hillshade data or on top of hillshade raster for the same area and use transparency to help us gain more information about the shading of the specific area. All right, so for this, we're going to load in another raster. We're going to go ahead and load in DSM underscore hill underscore harv. So this is the hillshade data. Again, we use the raster function, double quotes. We go into our folder data, raster, and then harv underscore DSM hill.tif, and press Control Enter. And we have some information here. So this is a warning. It says that the UTM projection is not a valid proj4 CRS string. So let's go ahead and check the CRS of DSM underscore harv. So it looks like the CRS for both our DSM harv and DSM hill harv are missing. I think for our purposes of layering rasters, this will be okay, but this is something good to see, so to be able to debug or understand what this warning is. And again, this is a warning and not an error. All right, so let's go ahead and look at what this looks like. So DSM underscore hill underscore harv, let's Control Enter. I'm told some information about this. So we're told that this is a raster layer. We're told the number of cells, number of columns, number of rows, number of columns, number of cells. Told the extent of the raster. Again, here we don't have a CRS, which we were told by the warning. We're told where this raster is located, the name of it. We're given the min and max values as well. So the first thing I want to do here is we're going to convert this to a data frame. So we're going to call it DSM underscore hill underscore harv underscore df. And again, we use the function as.data.frame, open parentheses, DSM underscore hill underscore harv. And then we specify the argument xy equals to true. Press Control Enter. So we see here now this hill data frame is in our environment, and we can see that it has the same number of observations as the previous DSM-Harv data frame as well, which is great because we're going to layer them on top of each other. If these two didn't add up, that might be an issue that would be worth exploring and might lead to some issues in plotting as well. All right, so let's take a little look at this data frame. So let's look at the structure using the str function, open parentheses, dsm underscore hill underscore harv underscore df, press Control Enter. And again, we see here we have x and y variable, and then our variable of interest, or sort of what's going to be plotted, is this harv underscore dsm hill variable. And we see that the first observation is actually missing, so we do have some missing values. All right, so the next thing we want to do is plot this hill shade data. And what we're going to do is we're going to add some transparency with the function scale underscore alpha, and we're going to specify the argument range is equal to concatenate open parentheses 0.15 comma 0.65, and that's going to specify the range of transparency that we want, how much transparency we want to allow in our plot. We're also going to specify guide is equal to none, so we don't want any additional legends in our plot for this transparency. We just want it to sort of be there. All right, so whenever we want to plot, we start with the ggplot function, open parentheses, plus. We use the geom underscore raster geom. Let me move this down a little bit. Okay. Then inside of here, we're going to specify this data frame name. So that's data is equal to dsm underscore hill underscore harv underscore df. Such a mouthful. We specify the aesthetics, AES, x is equal to x, y is equal to y. And now we have this argument alpha is equal to harv underscore dsm hill. So we want that to be the transparency. And now we have this additional function, scale underscore alpha, open parentheses. We want to specify the range of transparency, again, to be between 0.15, comma, to 0.65, comma. We specify the argument guide is equal to none, because we don't want this transparency to be included as an additional legend. And the thing that we always need with geom raster, that's going to be chord underscore quick map, open parentheses. We'll press Control Enter. Again, no errors here or warnings. Now we wait for this raster to generate. And now we have generated our raster, so we can see that there's different amount, well, we can kind of see that there's different amount of transparency here. And we can see that maybe this area is a little shadier over here. Everything else looks fairly uniform. So this is a little bit about plotting with transparency. I encourage you at your own time to maybe play around with some of these values to see how your raster would change. Again, be mindful that this specific raster kind of takes a few minutes to generate. So think wisely about which values you want to try and test. So the whole point of this is that we can layer different rasters on top of that. So let's finally get to that. So layering rasters. So again, we start with our ggplot function. So that's ggplot, open parentheses, plus. We have our geom underscore raster geom. We specify data is equal to dsm underscore harv underscore df. So first we're going to plot that dsm harv data, and then on top of that we're going to go ahead and plot this hillshade data. So comma AES, x is equal to x, y is equal to y. Fill is equal to harv underscore DSM crop plus, and we're going to use this geom underscore raster geom again, open parentheses, and we're going to include the same information the same geom information and scale alpha information that we included for the hillshade data. So mind you, we've now created two separate rasters separately, figured out the code for that, and now we're adding that code together to make one layered raster map. All right, so that's geom underscore raster. That's going to be data, oops, not caps lock. Data is equal to DSM underscore hill underscore harv underscore dia, comma, AES for aesthetic, X is equal to X, Y is equal to Y, alpha is equal to harv underscore DSM underscore DSM hill, plus, we're going to change the color scheme a little bit. So we're going to use the scale fill underscore viridis C for continuous, plus scale underscore alpha, open parentheses, range is equal to concatenate 0.15, comma, to 0.65, guide is equal to none, so this is for the transparency. Then plus, let's add a quick title, GG title, open parentheses, double quotes, elevation with hillshade, pardon me, plus, of course, your favorite chord underscore quick win. Oof, all right, let's give this a spin and see what happens. Now again, we're plotting two rasters on top of each other, so this will take quite a few minutes. Or maybe not quite a few minutes, but a little bit of time. All right, and now we have our layered rasters on top of each other. Notice here, that area I'd said it had a little more hill shade. It's now this darker color because there's less transparency there. Everything else, recall in the hill shade data, is fairly uniform. So we have a little bit of shading there. We see that this continuous color palette now shows us where there's highest elevation. It looks like it's right around here in that brighter yellow color. So with that, we are ready for our second challenge. All right, so for challenge 2, we want you to create a DTM and a DSM map for SJER. Recall we had the Harvard site field and then the San Joaquin site field. So we're going to use different rasters to do something similar that we've been doing with the Harvard field. So use the files in the SJER rasters to create a digital terrain model, DTM, map of the San Joaquin experimental range, SJER, field site. And so the rasters that we're going to use can be found in folders data /raster. So the first one is this SJER underscore DSM crop.tif and data /raster /SJER DSM hill.tif. So these are the two rasters that you're going to use for this challenge. So in this plot, make sure to include hillshade in the map. Label your axes on the DSM map and exclude them from the DTM map. And we're going to include a title for each map as well. So we're going to create them separately. If you want the additional challenge, go ahead and layer them as well. All right, so let's go over the solutions to challenge 2. So this is challenge 2, solution, or I think I did a colon. Solutions. So the first thing we want to do is to import, so let's go ahead and import the DSM maps. So that's DSM underscore SJER. We use the raster function, double quotes, navigate to this SJER DSM crop.tif. Again, we have this warning message. For our purposes of plotting here, that's okay. We're going to temporarily ignore it. Then we want to convert to data frame for plotting. So DSM underscore SJER underscore DF as.data.frame, open parentheses, DSM underscore SJER, comma, XY is equal to true, control enter. So there's even more observations here. We have what, 1,635,426 observations. Let's look at the structure. So again, we have our XY coordinates and our DSM of interest, SJER underscore DSM crop. Now we want to do the same thing with the hillshade data, so import hillshade. So DSM underscore hill underscore SJER, raster function to load it in, double quotes, navigate to data raster SJER underscore DSM hill dot tiff, control enter. Again, that warning that we're going to ignore for now. We want to convert to a data frame. We're going to go ahead and create DSM underscore hill, lowercase hill, underscore SJER underscore DF as.data.frame, open parentheses, DSM underscore hill underscore SJER, and XY equals true. All right, so now we're ready to build our plot. So we start with ggplot, open parentheses, plus geom underscore raster, data is equal to DSM underscore SJER underscore DF, comma, AES aesthetic, X is equal to X, Y is equal to Y, comma, fill is equal to SJER underscore DSM crop. Let's set alpha equal to 0.8. All right, so if I were to just run this, let's go ahead and do that. This will just give me the hillshade data. And if we created a similar ggplot with the DSM data, with the DSM data here, we would get the other raster, so without the hillshade. So in the interest of time, and because just one of these takes a long time to load, I'm actually going to go ahead and layer them. You could, and for your challenge, it's totally fine if you created them separately, but just be aware that really the goal at the end is probably to layer them for your interest, for any scientific endeavor. So I'm going to go ahead and finish typing this out. So plus, now I'm going to use the other raster, so that's geom underscore raster, open parentheses, data is equal to DSM underscore hill underscore SJER underscore DF, comma, AES for aesthetic, X is equal to X, Y is equal to Y, alpha is equal to SJER underscore DSM hill. So here I'm having the alpha parameter value vary according to that, according to SJER underscore DSM hill. This is different than above here, where I set it explicitly to 0.8, meaning I really don't want that much transparency. So transparency of 1 would be no transparency. Transparency of 0 would be transparency of 0 would be equivalent to having complete transparency, so no colors would show. So here 0.8 really isn't that much. So we get a warning here. Restarting interrupted promise evaluation. I think for our purposes, this is okay. We're also going to ignore this warning in this case. But here we can see the plot that finally generated. So this is our hillshade data for the SJER. And we can see that it looks like there's more hillshade over here at the very bottom than there is at the very top. So let's go ahead and finish writing out this ggplot statement. So this all looks good, and then we're going to add that scale underscore fill underscore viridis underscore C for continuous. We will specify this new way to set what these legends are. They're also called guides. So this new function guides, open parentheses, fill equals guide underscore color bar, open parentheses. So there's a slightly different way to do things. We have scale underscore alpha, open parentheses. Now we want to specify the range to be 0.4 to 0.7 for the hillshade data. Guide is equal to none. Plus, now we're going to do the X labs. So that's UTM easting coordinate in meters, plus Y lab open parentheses, UTM northing coordinate in meters, plus GG title, open parentheses, quotes, DSM with hillshade, let's call it for SJER to be specific. And finally, our favorite, chord underscore quickmap. There we go. All right, so this will take a few minutes to generate. All right, so after a few minutes have gone by, we finally have our hillshade data for the San Joaquin experimental range. So we see that same hillshade in the bottom area of this plot. There's more hillshade than at the very top. And also we have this range of a DSM, and we can see that the higher DSM range, so the brighter yellow colors, are at the top of this map. All right, so now we've learned how to plot more things using rasters in ggplot. We have our episode 2 underscore plotting raster.r script that's in red, meaning it's not saved yet. So I'm going to go ahead and press Control S to save it. And with that, we are ready for episode 3. Thank you.